Hello, everybody. Welcome to MSDOSX bonus lecture number 4. We've switched the order of the next two lectures. They work in synergy with each other, Core Data and iCloud. So this one, it makes more sense to go from the ground up, build some of the foundation with Core Data, and then we'll talk about iCloud specific stuff next time. This in the past has been very this is a very rich subject. So what I'm going to try and do is, what we've tried to do is boil a lot of the information down into kind of a conceptual 10,000 feet up overview, and then we've got a bunch of resources for exploring later. And there's also an optional lab for today as well for both Mac OS X and for iOS Core Data. All right, let's jump right in. So, what is Core Data? So Core Data is a framework that comes with OS X and iOS. It has undo and redo that's far beyond just regular text editing and word processing. Undo and redo of object creation and object deletion and merges. It also has a validation of your objects and ways to automatically validate the input and output of your objects. It also handles relationships, which we'll talk about here in a second, between objects, so that when you have a change being made in one object, another object will know about it, whether it even exists in memory or not yet. Pretty cool. It also is responsible for maintaining the integrity and the consistency of the relationships that have been established. And there's a ton of framework code that handles a lot of this stuff and handles most of this stuff for you. There are things in place that we're going to talk about later that allow you to sort and filter and organize data and collections of data very quickly. It also can keep data in memory as well as on the disk, and it does that very effectively in terms of caching and minimizing the memory footprint, and also has support for external data repositories like cloud-based storage, which we're going to talk more about next time. So there's some prerequisites to using Core Data. Objective-C, obviously, memory management is a crucial part of Core Data. You can get away with kind of messing around with Core Data and kind of experimenting with it and storing and retrieving small chunks of data. But once you start growing into full app size, you're going to need to understand how memory management works, which is another reason that we've been so consistently talking about it when the magic of Arc exists. You also need to understand delegation to a pretty decent extent, and how you can have objects delegate for other objects without subclassing them. And then Core Data is built on the principles of MVC, and so I'm going to talk about that in just a second here. And then there's also a new thing that we haven't discussed yet, and that's key value pair encoding and key value pair observing. I'm going to mention that briefly, and it's going to be woven into a couple of the topics later on, but I'm not going fully in depth with it. There are resources in the slides, at the end of the slides, to get you started on that. It's a very powerful paradigm. Actually, let's talk about that right now. Just as a quick, brief overview, key value coding is a way that you can reference data members and reference members of a class and do it by name, as opposed to doing it through specific memory accesses like the dot property accessors and getters and setters. It's an automated way for you to traverse an object hierarchy, object graph hierarchy, which we'll talk some more about. It also ensures that you would keep your data all encapsulated and keep things in place and keep it and make sure that you'll see the importance of this later on. But make sure that you maintain a very consistent access to your data and to your structures that are referenced within your data. It also allows for some oversight that can be put into place. So as you start referencing things, the compiler and the framework are able to better adjust for memory and for speed and for integrity, especially for data integrity. It's able to do validation on the fly. It's used very heavily in core data. It's also part of core bindings, COCO bindings, which we're not going to discuss for this semester, but there's plenty of resources out there if you're interested. That, in a nutshell, is a way that you can keep your data and your user interface linked tightly together so that changes in your data automatically reflect in your views and vice versa. There's more, like I said, there's more resources at the end of the slides for understanding key value coding better. It's pretty simple, and I'll show you some examples of it as we go. So, just very briefly, model view controller, very, very important. Controllers up here at the top, views are on the right, user interface on the right, the models on the left. We're going to be focusing on the model for this. This is what core data is all about. Core data is all about your model. So, diving a little bit more deeply underneath the hood of MVC, if you look at kind of the overview of where functionality and data sits in terms of MVC, when you've got your model, you've got your documents, and your data objects are here. Here's your controller that encompasses your application and the run loop and the event loop, as well as your application delegate and your view controllers are all here under controller. And then in your views, of course, you've got the underlying windowing system, as well as your views and UI objects. In this graph, it's all color coded so that white are custom objects, blue are either system or custom objects, and green are actually system objects. So you can see that in the whole pattern here, including with COCO data, if you've noticed that there's a whole lot of functionality that's built into COCO and the iOS and OS X frameworks. There's a whole bunch of functionality that's built in that's heavily optimized for it. So you can do some really powerful things with only a few lines of code. So let's talk a little bit about some terminology, some terminologies that are used in the core data documentation, and just so that we can all be kind of on the same sheet of music. There's this idea of entities, and entities are basically just like your classes. They're basically your chunks, your lumps of data that's organized and collated together in a way that makes sense to you and makes sense to the users of your API. Then there's attributes, that make up the descriptions of each one of those data elements, basically like tags for the data elements. In this case, we've got an employee entity, and we've got a first name and a last name and a salary, and they're represented here in this view. For each one of the individual entities is represented here. The attributes are represented. The values of the attributes are represented here. So, like I said, this is just showing you the relationship between that and the attributes and the entity, and how you can use those attributes in your views, in your view controllers. So, in this case, if we've got an employee object, the way that we reference this value for his salary is salary.value, which should look really, really familiar. And we're going to see some more extensive use of this later on, and you'll see the kind of the difference between just the regular property operators and key value coding in the way that it's handled. Cardinality is the relationships that your objects have with each other, and how many of those relationships are two-way relationships versus one-way, and how many of those are single point to single point, or single point to many point, or many many points to one point. In this example, we have two entities. We have a department and we've got an employee, and the department has got just once a reference out to the employee. The employee, because if a department has a list of employees, they're only going to have one reference to each one of those employees. However, employees may say belong to multiple departments, or they may not belong to any department. So in this case, we have a one-to-one reference from the department to the employees. We've got 0 or more references back from the employees to all of the departments. We've got an employee can have no managers if they're a manager themselves, or they can have one manager. And then you've got direct reports, the number of people that are directly reporting to you. If you're lowly on the totem pole, you don't have any, or if you're way up there, you may have some, the employees that report to you directly, there may be a number of them. So 1-to-1, 0 to many, 0 to 1, and you'll notice that this relationship is circular, which is when you're looking at this and you look at some of these object graphs later on, and I'll explain that in a couple of slides here, but as you're looking at some of these, you will be able to have entities that have connections to other entities. So you have an employee, if you have a bunch of managers and you've got a bunch of people that work, say, in sales, and a bunch of people that work in legal, they're all employees, but they may be different types of employees, but they can still have connections to each other. If you think about a family tree, you've got people, right? And you've got brothers, and you've got sisters, and you've got cousins. So they can all, you have relationships between those people. You have relationships between these employees. And this will make a little bit more clearer sense when we look at a larger object graph, which we're going to do now. So in this case, we have two types of entities. We've got departments and we've got employees. In the department, we've got the attributes are name and budget and a collection of employees. So if you're thinking an array of employees, you're on the right track. So we've got the department's got a name and a budget and a collection of employees. For each one of these elements in this collection has got a reference to an employee. Each employee's got a first name and last name and a salary. It has a manager, possibly has a manager, I should say, sorry. It possibly has a connection to a manager. It's got a connection, 1 or 0 connections to 0 or more connections back to the department, and then it has people that it might be directly reporting to them. So this person here, that Tony Lau is a manager and has Joe Jackson is one of the people that reports to him. Here's how all the connections are made. The employee's got 0 or no managers, has got a department connection, and has got the people that report to it. In this case, Tony's got Joe reports to him. Joe's manager is Tony. The department that he works in is marketing, and there's nobody who reports to him. So he's the lowly man on the totem pole. So if you look at these relationships can be circular, which is fine. It's no problem. And we'll talk about how this relates to memory management in a little bit here. But you can see that there's clear paths to reach members or entities that are within your collection of data in your relationship hierarchy between your objects. So here's an example of using the key value coding to get at the specific attributes and get at the attributes within entities that have a relationship with each other. So let's say we've got an instance of an employee. The way that we pull them out is we've got an instance of our department, and we say, all right, I want the first person that's in. I want the second person number 1 in our collection. I want to pull that person out, and I want to make him this is our employee. So it's just like it's like reaching into a regular collection, except you'll notice here that instead of object at index or directly object at index, we've got object and employees at index. So you can start to see how your methods can now start to encompass a way that you can reference other entities that are within that collection. So we have object and employees at index 1. Here's our department. Here's our employees. We want person number 1. So we'll get Joe Jackson out, and we're going to say, all right, we're going to start at Joe Jackson, and that's our instance of our employee. So we say, okay, employee.manager. So we look at Joe's manager, who is this employee, Tony. We say we say employee.manager.department, and we get his department, and we ask for the .name to get the name attribute. This is what the entire thing looks like. Employee.manager.department.name is marketing. That's how you reference your objects within your graph. So now we need to start talking about how this can all be implemented and how all of this can start to make sense, and how the framework can handle these types of graphs and relationships between entities. So core data itself has a lot of built-in functionality, a lot of free functionality that comes with it. Not only is it very well bug tested and very speed optimized and memory optimized, probably. And they mentioned this in the documentation a couple times, and I firmly believe it. Probably much better than you could do. I'm saying you as in the royal we. So there's things like there's an undo manager that handles when you start setting attributes for entities and getting attributes and deleting entities. It handles all of the undo for you. So when the user hits undo and you have an action for an undo action, you just tell the undo manager, undo that last thing. You don't even have to keep track of what's going on. It's all handled internally for you. It also has a layer for, and we're going to talk some more about this in a second, for persistent storage. Whether you're keeping objects in memory or you're saving them to the disk or saving them out to an external place, an iCloud or a server. But to be able to do all of this, we need to have some way to relate all of our entities and put them together into one context that makes sense. So NS managed object context is the name of the class that manages a collection of managed objects. And we're going to talk more about what a managed object here is in a second. It's not quite as nebulous as it sounds, but just keep in mind that the context is responsible for managing all of those entities, not necessarily managing just specific instances, but managing at a higher, more meta level, managing the entities and the relationships between them. The Apple documentation is pretty concise here. They form a group of related model objects that represent an internally consistent view of one or more persistent stores. Just kind of keep that in mind, and we'll explain each one of these pieces here in a second. But just kind of keep that as a kind of a broad general overview for what a context is. It's described as an intelligent scratch pad. It handles caching, it handles conflict resolution, undo, like I said. It unarchives objects, pulling them from persistent stores on demand. So it doesn't load your whole entire object graph and all of the related entities. It doesn't load everything all at once. It's all done on the fly. It's all done dynamically. It internally builds the graph, the object graph that you saw. You can go ahead and you can freely modify these objects and these entities that you've got in your context, and until you save it, they don't get stored anywhere. So you're free to modify, change, and delete, and then you can decide if maybe you need to revert. Maybe you need to resolve some conflicts if multiple people have access to the same entities. Or you can go ahead and save it in multiple different places. We'll talk about saving here in a second. But just keep in mind that it keeps the references all in memory, and they aren't actually written out to the disk until you actually save the references. So NS, so you've got a context for all of these, for this collection of objects. And these objects need to have some additional information that goes with them along with just the contents of your class. So that's what the NS manage object is. You can think of it in terms of like an NS object. You know how that's kind of the generic parent class for objects, and that everything eventually branches off of that. You can kind of think of it in that terms. You can think of NS manage objects are NS objects that have a couple more fields, and we'll talk about that in a second, but have a couple more fields that are able to handle the interactions within a context. Every core data object has got an NS manage object wrapper around it, and it also needs to belong to a context. You're getting a lot of terminology, and there's some images here that should help explain this. I know that I kind of got lost in terminology the first time I went through this. Manage objects are installed in one context and one context only. You can't have objects within different contexts because they wouldn't know how to keep in sync with each other. The context tracks all the changes that are made to that object, and if there's any objects that reference it, they all get notified, and they get notified, and they get notified. All of that's handled for you. So let's take a look at what a managed object looks like. So this is our entity here, and our entity is an employee. It has a name that's associated with it. It has a class that's associated with it. So this is typically the class that you want to have managed by core data. And then it has some properties. In those properties it's a collection. Each one of these instances in this collection are what are called descriptions, which are basically, here's an attribute, here's what type it is, and here's the value of it. So in this case, we've got one of the attributes is a first name for this employee. It's a string, and there's a class that's associated with the value, and that's NS string. In this case, salary, which is a decimal number, and it's an NS decimal number, is the type. And then we've got a relationship description. This is the relationship is the department. Remember, we have the employees that belong to a department. So it's got a department. It has a maximum count associated with it. This is one of the nice things about core data, is that you can do not only validation, but you can also initialize objects with values and validate and verify that your objects are correct in your object graph perfectly and consistently. It provides a snapshot of what's in the store, what's in the persistent store. And in this case, the destination entity is a department entity. So the NS managed object model it's basically the schema that you use that defines your managed model. So there's a reason that the suffix is model, because this is your model. NS managed object model is your model, if you think of it in terms of the MVC pattern. So it's usually created in two different ways. It's created with, actually, it's only created in two different ways. Either with the Xcode data modeling tool, which is incredibly cool, and I'll show some screenshots in a second here, or you can do it in code if you're really hardcore. It's not super trivial. The tutorial goes through it, and it's an excellent learning experience, but it's not something I would ever want to do on my own.
It's a lot of boilerplate code, doing it in code.
Right. So the model describes each entity and describes the relationships that it has, along with the classes that are associated with each one of those entities, and any additional properties that your class may have, that your managed object class may have. So this is our entire model. We're modeling a HR portion of a store, and we have are two entities. We've just got a department and we've got an employee. That's it. this is our entire model. It's two entities. These, you can think of these as, essentially this is your class, and you'll make instances of your entities. It's got the object model, like you saw just previously. Each one of the entities has got a name. It's got a class name that's associated with it, is directly associated with it, and it's got an array of properties. To access and to get at the objects that are represented by your model, you use fetch requests. Which, how many are familiar with SQL or one of its variants? It's kind of, sort of, a little bit. Okay. Essentially, it's a database. It's essentially a very scalable database, and one of the underlying technologies for core data is SQL. However, you'll see in the documentation over and over and over again, it's not just any regular SQL database. You can't just create it and smash it into core data and have it work. It's very specific. So if you're going to be building up a core data database, you're going to want to do it through core data. There's ways that you can import and export. There's ways to import, but it's not it's a really trivial process. So you're much better off modeling it and building it and keeping it within core data. That being said, that allows you to do some really, really powerful fetching and grabbing of objects that meet a certain criteria. It's each one of the, you build up a search, you build up a fetch, and then you go and send it off to the context to go and find all of the objects that match specific criteria. It needs to have a name for the description that you're looking for, and then it can also have predicates as well. And I'll show you some examples of the modeler, which is just amazing. For instance, you can go and ask for, actually let me save that because the next slide has got an example of what a fetch request looks like and how it works. And then you've also got a sorting sorting descriptor that can go in there as well. So you can say, I want these objects that match this criteria, and I want them sorted by this using this other criteria. And you'll get these objects back as a collection, and you can just start burning through them. So here's kind of the anatomy of a fetch request. You've got the name that you're looking for, the entity name that you're looking for. That's the description that you're looking for. So we're looking for an employee in this case. Our predicate is we want to specify that we only want to fetch back any of the employees that match this predicate. In this case, the predicate is the department name is marketing. So we want to find all the employees that are part of the marketing department. Then we've got a sort ordering that says that we can also apply to our fetch. And in this case, we have two different descriptors that we're putting into the sort. We're saying, okay, I want to sort by the salary, and I want to sort it in ascending order, and I want to also sort it by, to then sort it by the last name, and also do that in an ascending fashion. So in this case, I have to fit one of those in there each time. Sparkle. It's so ridiculous. So in this case, I just kind of highlighted the salary as the initial, the only sort descriptor here. I'll update this to show that it is sorting by salary and then also sorting by last name. So in this case, it's going to give us back. Let's say we're just sorting by last name here, I believe. Yes. So Kevin's making $3.50, and Jordan, who hasn't been here quite as long, is making $2.13, and I'm making $1 billion. Okay, so underlying all of this, so we've got this incredible memory model. We've got this incredible relationship between all of these things. There's got to be some way to store this somewhere that we can use it later. That's all done through what's called the NS Persistent Store Coordinator. That basically allows for contexts to look at stores, and they may be multiple stores. They may be stores that are existing in memory and on your hard drive and in the cloud. It gives the illusion to the context. It gives the illusion that it's all one store. So the context doesn't have to worry anything about any of the underlying functionality of saving these objects. It just sees a place that it can store things, and it just says go. The persistent store coordinator is responsible for not only managing that and managing these multiple stores, but it's also responsible for flagging conflicts. So if you have multiple documents, if you have a document up on iCloud and you've got it open on multiple machines, this is the guy who's initially responsible for making sure that everything stays in sync. And if you save something on your phone, this is who's going to be first notified, and it's going to notify all of the other entities that something has changed. So here's some words for it, and then I'll show you a slide here in a second. At the bottom of the stack, if you imagine this as a graph, at the bottom you've got all the actual stores that are all pulled into one to look like one virtual store. Above it, the managed objects, your managed objects are at the top, and the persistent store lies in between. So if we have my persistent document here that has our object context, it has all of our NS managed objects inside of here. Here's where the store coordinator fits in. The store coordinator sits here. The persistent object store is something that it uses internally underneath the hood that the context doesn't have to worry about, and especially you don't have to worry about. The persistent object store is responsible for doing all of the file handling and all of the SQL and database transaction work. Then this is presented by your document. This is presented without having to know any of the specifics of what's going on underneath, and having all of that stuff stay in sync, and all of those objects being notified when something has changed, whether it's on a different store or it's living in a different part of your object graph. So let's actually, we're only going to touch on this. This is something that you're going to want to take a look at if you're doing any form of, if you're going to be creating, allowing your users to create data on a document. This is typically done with a persistent document. You've seen a lot of this in Lion, where as you're typing away, whether it's saved on the cloud or saved locally, or you haven't even hit save yet, it's constantly keeping all of that stuff in sync in the background. That's all handled automatically by an NS document. So an NS document is one example of a managed object. It is a persistent document. All this documentation is in there in the Xcode documentation or the developer documentation. So I'm just going to kind of briefly touch on this, but this is something that you'll see in the documentation kind of scattered around, because this is the uppermost level. This is the highest level where you are. It's Cocoa and it is handling an iOS. iOS has UI documents, doesn't it?
I think it does now. Yeah. They might be NS. I think they're NS documents there too.
Still in it? Oh, it's also NS documents.
Yeah. Oh,
okay.
They're not part of UI kit.
Gotcha. Okay. So regardless, this is the highest level that is presented to you with the most functionality. You're able to write a text editor that has all of the iCloud saving and synchronizing and undo and redo with a couple of lines of code. And this is how you do it. You do it with the NS document. It's got your NS document, your highest level NS document has got a whole bunch of collections in it. And each one of these collections has all of your entities in it. The undo manager is part of the document. That's all boilerplated for you. And all you're basically supplying, if you want to, is how to save and load the very specific chunks of text or data that you want. That's unique for your application. Everything is all handled for you under the hood, and you don't have there's very little code that you have to write. It's pretty amazing, and I've started to use it now, and there's so much functionality that it's just ripping out huge handfuls of code that I don't need anymore. It's really worth taking a look at the documentation for. So, like I said, you can build these models in code. Like we said, it's pretty painful. It's not very trivial. However, Xcode in interface builder fashion has got a modeling tool where you basically lay out your object graphs visually. I'll show you some examples in just a second here. You basically can build all of your entities and all of your relationships to your entities within this modeler. You define the whole scheme. You're defining the whole NS managed object. What am I looking for? Model. The NS managed object model. You're building it all with the modeling tool. It becomes part of your built application, much like the nib files. It's pretty much the same thing. It's the same idea, not the same thing, but it's the same kind of idea. It's all bundled in with your application. It's all referenced right there. It's used at runtime, so as your application is starting up, part of its normal cycle is to go in and build this entire relationship behind an entity relationship, entities and entity relationships, all behind the scenes, and present a unified way for you to access your data and to save and model your data. It's amazing. You've seen on the left-hand side, you've seen in this columns, now you've got an opportunity to mess with another one of these rows in the column on the left. This is your data model is your overarching schema, and then you've got mapping models and NS managed objects. Those are objects that you've created that you want to manage. You can subclass them or you can wrap them around your existing classes. Here's what the modeler looks like. In this case, we've got 3 entities that we built: ingredients, a recipe, and a chef. They all have relationships with each other. So if one of the chefs changes a recipe, if one of the chefs loses an ingredient for a recipe, any other chef who is connected to this recipe is going to be notified about it. So it's all built graphically. It has incredibly rich tools for building all of your entities with your attributes and a lot of the flags that are associated with those entities. You can build almost your entire model within the modeling tool. You specify classes just like you do an interface builder. The connections, everything is all drag and drop, so all the connections are all built graphically. You can see what's got a relationship to another, entities that have relationships to each other. You can see if there are many relationships or single relationships. Did you have a question? Yes. Uh-huh. Yes. Yes.
Yeah, so you can't just throw NS objects into a managed object conflict. It has to be NS managed objects.
Because the NS managed objects has got the description and the name and the properties that are associated with that object.
Yeah, it's a direct subclass of NS object.
Yeah. So that's what I was saying is you can kind of think of it in those terms. It's basically an NS object that has some additional data that's been tacked onto it that the context is expecting that object to have. The context needs to know what the name is and what the associated class is and the properties that make up that object. Does that make sense? I encourage you to explore this and in the labs, just kind of a preface. The optional lab for today is to go through some of the core data tutorials. One of them has you build everything in code and build the entire thing in code. It's a very simple program, but it gives you a real kind of fundamental understanding of each one of the concepts of core data and gives you better appreciation for the graphical modeling tool. I would recommend that if you blaze through that, build the application in the object modeler, and you're going to see that it's a tenth of the code, because you're able to model, you're able to build all of your data modeling visually right here, and then basically just say, okay, I want this connection to this connection to this connection to the value of this connection, and it works.
I've always just loved how much it looks like a UML diagram.
Yeah, it's definitely been based off of that for sure. You can build fetches in the modeler as well, so you can have incredibly complex predicates for your fetches, and you can build all these ahead of time, and then basically when your app is running, you can just say, give me the fetch named first name and last name and under this budget and over this salary. Give me the fetch that's associated with that, and go. And it works. It's amazing. There's a ton more to core data. This is just a really super brief overview of it. There's also documentation on the persistent stores that are using, that are the underlying the persistent store manager. Essentially there's XML. There's an XML human readable-ish form of your data. There's just strictly binary blob data, and there's actual SQL building SQL databases out of the persistent store, into your persistent storage. There's also versioning is also amazing, where basically you can, as your data upgrades along with your application, you can have an automated and very internally consistent way of handling data migration from version to version. It's also incredibly cool, very well thought out. There's a bunch on optimization in the documentation. As your data starts growing larger and larger, you want to start thinking about how do I bundle all of my fetches into one fetch and have it happen all at once? How do I push objects that are old and not being needed back out to the store when I want to keep something in memory? A lot of different trade-offs and things like that that are listed in the documentation. There's also bindings, like I had mentioned at the start, which tie your views and your data together automatically. They take the controller out of it, and essentially they act as a controller. It's not available for iOS, unfortunately, for core data. Bindings in general exist for iOS, right?
Yes, maybe. Not 100%.
I haven't used them in iOS yet, but unfortunately, they aren't available for core data in iOS yet. But they have been for a while for the Mac or for OS X. There's also whole sections on conflict resolution, what to do if two different consumers of your data modify the same entity and modify the same instance of an entity, and how to handle that. There's multiple different ways that you can handle it, and it gives you the power to do that, and list the trade-offs and the advantages and the benefits. And then, of course, there's the iCloud connection to all of this, which we will talk about next time. Lots more. So there's resources at the end here. Here's a kind of a rundown of the key value coding that we talked about previously, or talked about at the beginning. There's the core data basics to get you started with the terminology and understanding the underlying concepts of core data, which we just skimmed over today. There's the guide that for the modeling tools, for the visual modeling tools. There's a document for optimizing core data using instruments. There's a whole bunch of instruments that are all built in that can monitor and measure core data performance, whether it's speed or memory. So I recommend that you take a look at that too if you're interested in using core data on a larger scale. And then the optional lab, there's the OS 10 version and there's an iOS version. They're slightly different from each other. I think they're written by different people, but they cover most of the same ground. And like I said, can't remember if the iOS tutorial has it uses the visual modeler or not. If it doesn't, do it in code and then make a version that uses the modeler. And if it does use the modeler, go back especially to the OS 10 version and see how this all works in code. Once you see both different approaches, it conceptually makes a lot more sense. I know that it probably doesn't make much sense at all right now because we covered something that can be...
It takes a long time and a lot of meditating to understand.
volumes of information compacted down into half an hour. But if you're interested in using it, and I highly recommend you check it out. It's something that I've started to incorporate into projects that I'm writing, and even if I don't need all that power, just getting comfortable and familiar with it because it is such an incredibly powerful framework. Questions? Cool.